All right, now this solution that you just looked at, how nicely everything is broken into steps. All right, this is my Disney version of doing physics. I do this to communicate how the solution is carried out, step by step by step by step, until you guys kind of get used to the format. So we will do the same problem, and we will do it the way you're expected to do it. This is going to be problem number 9. This is exactly the same problem, except these details are going to be missing. All right, it's going to be a real life problem. All these numbers that you're looking at, that all of a sudden I'm giving you all these amazing numbers, except the problem is going to be worded differently. All right, this is going to be your first university level physics problem, the way you will be doing physics problems in the future. Until you guys are kind of done with your engineering discipline, this is what's expected. It's the same exact problem, except instead of asking you 3 different questions, I get 1 single question. Hey, tell me the amount of time it takes for the car to come to a stop. That's it. That's it. It's not broken down nicely, so you get net force first, and then find the acceleration, and then find the amount of time it takes. Nope, real life is not like that. Real life is, hey, these are the things that we can measure, and we want you to find this. And we just convince us that that's the answer. No one is going to want to see all these numbers in between steps. No one. Right, so the first thing you would do is call the force diagram, which means that you have to set up the forces on the x and the y directions. This one is straightforward because we got 1 single force. It's pointing to left. Okay, so I was doing the lecture. I was a little bit too tired. So this should be x. This should be y. All right, hopefully I'm going to make a correction. I did. Okay, cool. All right, so this guy is moving in. It's got an initial speed. It's slowing down to a stop in that distance. So my question is the amount of time it takes. Okay, so notice that symbolically I'm just representing everything. Okay, this is, once again, let me make this point, even if you don't hear me right now. Hopefully, when you watch this online, you will hear it again, either before the test or after the test or about a month from now. If we're using vectors, guys, and we are, you have to draw things out. That's part of your grading. Okay, you got a visual image, and the only way you can convey that image to me is through these little diagrams. Okay, make sure everything is clearly denoted. Don't have a secret handshake here. You make one gesture, I go, wow, this guy knows what's going on, and he gets credit. No, just pretend that the person who's doing the grading has no idea what you're doing. Absolutely no idea. Convince me that what you're doing is correct. Welcome to life. So that's what we will do, because that's what I do whenever I'm teaching you guys. I just explain the hell out of everything. All right, so I'm just going to grab everything that we had before. All right, so these are the parameters given. And I want to know how long it's going to take. That's it. Listed everything. Everything has been converted. Now I'm okay. Everything is in the bank. There's nothing to savings at this point. I don't have to worry about any of the numbers. These numbers are known as the initial conditions. I know what's available to me in order to solve this problem. And I can model it anywhere, in any way possible. As long as I can use these numbers, I'm okay. I will come up with a solution based on that. That's what it means. So T is what I'm looking for. And there's a frictional force acting on the system. So if there's enough force acting on the system, any sort of force acting on the system is going to cause acceleration. All right, so which means that these are all the formulas available to me in terms of dealing with any sort of situation that's about to arise. So T is what I'm looking for. This formula is T in it. This formula is T in it, so is this one. Okay, now I have to make a decision. Do I assume that this is a variable force, it's going to give you some kind of jerking motion, or do I assume that for whatever reason the car is going to come to a smooth stop? All right, so I'll say, okay, so I can go with that, but instead I'm just going to assume that the car will come to a smooth stop. So, which means that I can either use this formula or I can use this formula. Okay, so this formula is a possibility, assuming that the acceleration is constant. I got an initial speed. I know the distance that it's going to travel. I can solve for T, so that's a possibility. Okay, so I'm happy with it. The only thing I don't like about this formula, T is squared, so that's a quadratic equation, so which means it requires a quadratic formula. So this one is actually messy. All right, it's more work than I need to do. It's math. I'm not a mathematician. I'm good at it. I find it boring. All right, and so that's not the fastest way to solution. So I'll say, okay, I don't care about that. I already made the assumption that the acceleration is going to be constant, so I'm going to focus on this one. This is uniform acceleration. This one means jerking motion. That's the average acceleration. So I'm thinking this is the one that I'm going to focus on. All right, so at that point, I write something out. I say, assuming that the acceleration is constant, I pick this formula. Okay, I'm not going to write it down here, but I would expect you to write it down. If it's not there, obviously there's going to be a deduction. So that's the formula that I decided to use. I'll check to see if I have any zeros, because before I do the algebra, I want to just get to the point real fast. The whole point is not to make mathematics really complicated. The whole point is I have a problem that I'm trying to solve. Let me get to it as fast as possible. So final speed is 0. So I'll drop that. And simple algebra is going to isolate T from here. And then once I'm at this point, I'm going to stop. I know the initial speed is what I'm looking for, but I don't know. I don't have an expression for A. What do? At that point, you guys are thinking, oh, dummy, it's really easy. Just go find a formula that has A in it. Guys, that's not the way we will do physics. We've been doing it for almost 6 weeks. Now it's understanding-based problem solving. We start to differentiate ourselves from those people who are mathematicians. You can have a PhD in math. You may not be able to do a simple physics problem because the physics is not a linear way of solving problems. It requires you to understand the concept. Is what I'm looking for. I know what causes A is acceleration. It's a net force. All right, that's it. I know what causes it. It's a net force. It's the Newton's second law. It's the net force acting on the system is responsible for it. I'm not just looking for formulas. Now I'm doing it intentionally. A is the acceleration. It's going to be caused by the net force. I have a visual for it. Hey, look, it's pointing in the opposite direction of the motion. So it's going to be negative. And that's it. All right. So this is the net force. So just plug it into that formula. And the net force is responsible for the acceleration. So this gets plugged in there. And now I have an expression for acceleration. So this gets plugged into that one. So there's a backward substitution one more time. And I need to clean this up. Negative divided by negative is going to be positive. And mass is a denominator of a denominator that becomes a numerator. And that's it. We're done. That's the final expression. Okay, so now that I'm at this point, I ask myself, do I have all the variables? Do I have the mass? Do I have the initial speed? Do I know the frictional force? And all of them are yeses. All right. I mean, everything is a yes at this point. Then you plug the numbers in, and when you plug the numbers in, you end up getting 8 seconds. So that's the extent of it. All right, everything that I've done in the symbolic algebra form is physics. It's not, oh, I got the same 8 seconds. Why did I lose all these credits? I don't care how you got to 8 seconds. Maybe you're a psychic. Maybe you can count up to 8. I don't know. That's not what I'm testing. What I'm testing is this algebra, the thinking that goes into it, the way I do my back substitutions, how clean the work is. Right? You mess something up, if there's an assumption which is wrong, or you just forget a square, or you forget something real simple, how long does it take to grade this? Guys, 15 seconds if I'm not focusing. All right, I look at it, everything is there, versions are there, you number, if it's off, I don't care. You lose marginal credit for it. But if the work is clean, if I can see everything clearly, perfect, we're good to go.